about this enhancement. I think this has been the biggest redesign for ASPI since it was founded in 2008. So first one, go here. Okay. So first we have a new logo on Windows. So you click the new logo and this is the new user interface for ASPI. When it opens, you see that the 3D visualization is embedded in as the main user interface. I redesigned the whole tabs here to make it simple. So for example, you have now the input export tab. I'm gonna show the demo. That is everything that is import and export data. It can be 2D seismic, 3D seismic, surfaces and wells are there. So before it was inside the GUI in different parts. Now everything is consolidated in just one tab. We have, remember that before we have the geometric, formation attributes, spectral decomposition, and single attributes. Everything now is embedded in just the seismic attribute tab. I will show you that as well. We have the data conditioning, we show you, and now the machine learning toolbox is inside this AI toolbox for seismic. So you will see machine learning toolbox and deep learning toolbox. I redesigned everything for the steps. I think the machine learning toolbox got a little bit complicated over the years, so I simplify everything in just 5 steps that you can follow. So I will show you that. So that is a new user interface. We also have the SegWide to VDS in the new user interface. It's a simple GUI right now. You get your SegWide volume. You can read the header. You just need to specify right now the XY, the line, and the CDPs, usual byte locations. And after that, it will give you a VDS volume that's the input for the 3D visualization. I will show you that. So this is just an example after I converted my seismic to VDS, and this is the one that it plots. So you will have the 3D visualization just right there as a maze interface. So key point here is like, this is really good for QC. So you will have your attributes, you can plot them, you can QC. When you like them, you can maybe go to your main interpretation package that you use in your company. So the AI toolbox, you see that I have the seismic word, is because this AI is just for seismic inputs. Then in the future, the idea is to have the AI toolbox for seismic well correlation, and then the AI toolbox just for well capabilities. So it's a little bit to organize what are the inputs and what you're trying to do. It's a little bit easier. As I said, I organize everything in just 5 steps that you can see here. The step 1 is just generate your training data. And that step 2 is just analyze the techniques. In this, is just a hyperparameter search. For example, you have a technique and you test different parameters to see what are the best. The step 3, you create your model. Step 4, you perform the model, the classification or the analysis in general. And the step 5, you plot the results. So I simplify everything in just 5 steps. Easier for everyone. I think it's gonna be great. One of the new capabilities that we're implementing is just there already, and is to have for ASPI, for us, it's not just about the machine learning technique, it's about the interpretability, the explainability of this machine learning technique. So now, besides CHAP, we also have the PCA attribute selection. So we can do attribute selection using principal component analysis. And it's just a new capability there in the PCA toolbox that you just decide that you want to do the selection. I will show you the demo as well. This is just an example. Right now, it does attribute selection per eigenvector. So you see the eigenvector number 1 is this example. The coherence is the most important attributes, followed by the GLC and energy, and then the entropy. When you see the eigenvector number 2, that represents 30% of the variability. The deep magnitude is the most important, followed by the GLC and entropy. And if you see the eigenvector 3, the magnitude is still the most important, followed by GLC and entropy. So based on this, you can select, okay, maybe I want to use the coherence, the magnitude, and GLC and entropy for my analysis, and then you can do that. And finally, the ASPI chatbot. So I have been working with this chatbot for a month already. It's the first version for the chatbot. It's a decoder only transformer architecture. So it's really good for generative AI in natural language processing. What it does is it's a self-supervised training. It's trained to learn what is the next token. Like, it's not exactly the next word. It's the next token. The token can have several words together. So let's say train the next token, then get a line, try to predict the next token. So it's a self-supervised because it's just training with their own training data. I don't have to provide labels. So it's really nice. It's trained from scratch. I'm not using any pre-trained model because I don't want my model to know things outside ASPI, So I train from scratch using PyTorch. I'm using only ASPI information. So the demo that I'm going to show you today is just training a subset of the ASPI short course information. It's very nice. The next step is to scale. So I trained this chatbot using this laptop, and it took 10 hours. And it's 100 million parameters. It's a really small. I know 100 million might sound big, but this super high-end chatbot had trillion of parameters. So this is small. Runs locally, so that's very important. It's not connected to any server. Anything that you type is test there. It's not recording that. It's not used for training in the future, so it's very private focus. So as I said, runs locally. The only thing that you need is a GPU because it runs is a GPU. So this one, it has an RTX 3060, I think. So runs really well. I'll show you that. It's coming later this year. Right now, I'm still testing. It's not available for sponsors yet. I'm gonna do a short demo for that. So let me just go there. So let's start with the demo with the ASPI new interface. So you see, I have my new logo. I have to select um, my folder as usual. It runs on Linux as well. So let me know if you prefer Linux. I can tell you how to do it, but it runs on both Windows and Linux. So you see that I open ASPI is the new user interface. I try to simplify everything in these capabilities as best as possible. If you have any feedback, let me know. I can modify. So the import export, as I said, you have 2D, all the 2D capabilities for seismic, 3D. We have the SegWide to ASPI. We have SegWide to VDS. We have CGY and Windows capability as well. Surfaces and then wells. Seismic attributes, you see, simplify everything in just single spectral geometric. In the geometric, I went a little bit deeper, and then I just compute everything for dips, similarity, curvature, texture, and disorder. So you see it's organized by the main topic, let's say. And formation attributes the same. We have flatten on flatten, we have strata slices, and we have formation statistics. So everything is more organized, I believe. Data conditioning, we have the spectral balance, we have the structural interfiltering, and we have this advanced workflow, and that's the one that Dr. Marfrey just talked about it. So one thing that I did is like everything that is like a source sort of workflow, I define it as a step. So you see step 1, step 2, 3, 4, 5. It's easier to follow. So step 1, generate demand filter, add spectral balance, SOF, 5 steps for the advanced workflow. You have removed predicted noise. So I try also to set up everything based on the general topic, like for example, similarity or reduce coherent noise or good for removing random noise. I don't know, based on the main topic. The AI toolbox, we have the machine learning toolbox, unsupervised, 5 steps, supervised, 5 steps. We have the deep learning toolbox, as I said, based on topics, false identification using CNN. So you can apply a pre-trained CNN model, or you can create your own custom model that is just 5 steps as well, plus visualization, 6 steps. We have the legacy volumetric classification. These are SON, 3D, and GTM. We are moving that to the machine learning toolbox. Takes some time. They are still there. And then we have formation analysis. That is the waveform classification. Like when you do PCA waveform classification, everything is in this AI toolbox. We have attribute correlation. We have visualization now based on topics. If you want seismic, you have the 2D plot and 3D plot. You can actually have several 3D windows individually if you want to do that. We have utilities. So some people were surprised that, for example, we can crop data on ASPI, so the things like I simplify everything in these utilities, so we have crop, for example, we have crop volume here, we have convolutional model, we have bandpass filter, amplitude spectrum. So everything that is like some sort of processes is there in these utilities. If you have feedback to get new utilities, let me know. Workflows are there. They were there before. I just simplify everything for geometric attributes, for print. So if you open them, they also has steps to follow. If you are nostalgic, maybe you like the ASPI util, you still have access to that. You just go and you have it. So it's still there. We are not gonna remove it. And if you are in the util, you can go back to also the ASPI main workflow. So you can open them recursively. So And we have also the pre-stack capabilities as well. So let me show you really quick two things. We have time. So on the import export, I go to 3D seismic, say Y to VDS. Right now I'm using this Cora. I just gonna do AASPI demo. It's very simple. I'm still updating some things here. I read my headers. I know that is 73, 77, 5, 21. It will run. We still have our terminal, to see how everything is going. It's importing right now. So this is using OpenVDS in Python, using the OpenVDS capabilities to import SegWide to VDS. So it's called something called SegWide import, and you put some parameters. So it said that everything is successful. We have the volume. And now I just go to choose my seismic volume. You see that I have VDS there open. And I see it's very, very, very fast. So I try to do it as interactive as possible. So everything changes on the fly. So you see, I just changed the color bar, it changed there. If I just go and move a little bit, you see that it's there. So what else? You can change also. I'm still improving. So for example, you can change the size. You can change the background color. This stuff. One thing, let me just import, you can remove it, for example, should work. And then let me import really quick. It's not in SegWide. Let me just do that really quick. We are still improving some of the SegWide single file. So I'm still improving some of let me show you, the conversions, BDS, ASPI, we are still working on that a little bit. So 75, 20, 21. Let me do this really quick to show you, because the way that I created this 3D is very smart to know what is the color bar that you should use, because that sometimes is critical what color bar you want to use. So just this ASPI, then see 73, 77, 5, 21.
Okay.
Yeah, yeah.
It's running. So you converted from SegWide to VDS.
Yes.
And processes in ASPI in output, it's going to be feeding in VDS, or creating a VDS file.
So Tan is working on that. So it's almost ready. The thing right now is like we're still improving everything, but the thing is like you will have your SegWide. And then you will have also right now it's a VDS. You have a VDS input and it will go to ASPI VDS, let's say. So it's using VDS to store the data, and it uses the .h files to actually read the headers. So everything works there, and that VDS will work completely with the plot. But the thing is like, yeah, you will need the VDS volume. What happens if you have a SegWide? So after that's ready, I'm gonna go a conversion that you can go from SegWide to ASPI and VDS. Everything is gonna work. You don't have this extra step. Right now you have an extra step to use the 3D. That's gonna take care of in a few months, So.
Can you say two statements for those who don't know what VES is?
So it's a brick format, virtual data storage. So it's brick format is really fast to access the data there. For a reason, the time slices that you see there is really easy to use. It's from Blueware. It was developed by Blueware. They have like some VDS proprietary format that it has more capabilities, but they were kind enough to release this OpenVDS under the OSDU open source capabilities for oil and gas, energy in general. So that's what we're using. Thank you for the reminder. And then if you see that I'm using energy ratio, you just use the color bar directly. I try to do it as smart as possible. So, and it's very, very, very fast. So any feedback, let me know. For example, the next step here is to do the co-render. So you can co-render volumes. And then I will import wells and horizons here as well. So it takes some time, This is just pure user interface. It's not research, let's say. So take some time. I need to put it in part of my workflow. So yeah, tomorrow I will show you the demo for the PCA if you're staying, if you have any question, but it's just there. Actually, I can do it really fast. So we have time. So I pre-compute everything. So you see it says unsupervised. I already generate my training data. So now I just go to analyze unsupervised machine learning models. I load my training data. I have my attributes. These are the ones that I'm testing. I can do the parallelization. That should work. And then I go to my PCA tab, and it's just simple step. Like, do you want the PCA attribute selection? I say yes. Right now, I'm using just this one capability. I'm working as part of my postdoc in another way to analyze the PCA. It's gonna be ready soon. And then just execute PCA. Take a few minutes. Okay, it's computing. So you see, I have my plots there, and I just analyze based on this. And based on this analysis, I just select my attributes and continue with my steps in the workflow. Okay, so